Hello everyone, welcome to day 23, another day of learning. In day 23, we are going to get back to Terraform and we shall be doing one more thing with Terraform that will be setting up a remote state backend. In a few minutes from now, I'm going to explain to you very clearly the challenges you can face or I'm going to face and you've seen me facing while working with a local state for Terraform. And I am going to show you how to actually set up this remote backend so that these challenges are not faced. So if you've been watching with me and learning around with me, then you know that this is a great day to learn and continue building our flight booking engine. Right now, we are focusing on the DevOps and we are looking at Terraform, which is an infrastructure as code tool. But before we go into that, now you remember yesterday I got an issue after creating our booking model and we made use of it. Okay, there was a typing issue concerning what is it called, RAF. Okay, RAF was not allowing me to push to GitHub because it was not taking note of this annotation. It was not understanding this annotation. Okay, even though our project was working, but this annotation was off to RAF. So the solution was to import this. Okay, but importing, saying from .users import user in DB was causing a circular import error because this file is importing user in DB and users.py is also importing booking. Okay, so it caused for us trouble. So the hack around it, when I did some research, was to import type checking from typing. Okay, and then we say that if type checking is going to happen, okay, and this is the case for like RAF, if we are type checking, then we do this. Okay, a simple hack to get around RAF linter. Okay, so let's get away from that and continue. So I'll clear my screen and let's get into Terraform. So and actually, after pushing this, you can see, if I can show you my browser quickly, the commit is right here. You see the commit says track user bookings in booking table. This is what we did in day 22. So if you missed that recording, please go back and watch it. Okay, and you see our infrastructure was created. Okay, Terraform init passed, Terraform validate passed, Terraform create tf file passed, Terraform plan worked well, and Terraform apply worked well. And we have some outputs here, okay? Like the application URL. If I click on it, you see, it is very okay and successful. We have our application. Now, I want to show you something, okay? In our current state, in our current setup, if I run this again, okay? So what is going to happen? I'm going to rerun. So I'm going to come here. I'm going to expect it to fail. So it says job. Okay, it's already now running. So we're now on Terraform init. Terraform setup Terraform is done. Terraform init is now running. Okay, so we're now on validate. We're now on tfstate. Terraform plan is running. Okay, now we're going to Terraform apply, and boom, it fails as expected. Now, why does it fail? Look at this. It says AWS security group dot app server SG creating, and says, let me expand this so that you can see it clearly. It says creating security group Airbound Ventures SG operation error EC2. Create security group, okay, status code 400, meaning a bad request, and says the security group Airbound Ventures SG already exists for VPC. Okay, but this is not supposed to happen. Okay, Terraform should be smart enough to know that on our, if I come in and refresh, you see on AWS we have the security group called Airbound Ventures SG. Terraform should be smart enough to know that this security group already exists and I should only update its settings but not try to recreate it. The challenge right now is that Terraform is not able to know, okay, whether this security group was created before. Okay, how it can know that it was created before and should not try to recreate it is by using the state file. Okay. So if I go back to our code and I show you that state file, where is it? I need to get out of this directory, probably close all this. If you go to Terraform directory, Terraform, I see this directory called terraform.tfstate. Okay. I actually added it to gitignore because it can contain secrets. So terraform.tfstate is the file that helps Terraform to track infrastructure it has created and infrastructure it has not created. In the event that it has created it, it will simply skip and not recreate it. In case it finds you've updated it, it will look at tfstate and update it in case you created it before. The challenge with us is that on our machine, on the runner that is running this GitHub action, Terraform state is changed every now and then. Okay, every time we push our code to GitHub, we get a new machine. Okay, and that new machine configures its own Terraform state, a local Terraform state file, which means every time we shall be pushing, we shall be getting new state. Okay, and Terraform will not be aware that it had created a security group before. It will not be aware that it had created an instance before AWS EC2. It will not be aware whether it created a key pair or anything else. Okay, that is the challenge we have right now. Okay, so the solution actually is to have a Terraform state for GitHub Actions that is always going to pass, that will always exist. Okay, but now in this GitHub action, you cannot have a file that is always going to exist, because every time you make a push, that file is erased. GitHub Actions reruns a new machine every time. Okay, and these machines are called runners. So it creates a runner and clones your code. Okay, and think of it as running a new project every time. And running a new project every time means you have a Terraform.tf state, a new Terraform.tf state every time. So you cannot track what is new, what has been updated, what should be updated, what should be deleted, what has been deleted. Okay, that's the problem. So what we can do is we can have if our TF state, okay, our Terraform state on a platform like on AWS. Okay, we can use AWS S3 to store our state. Okay, so store the state on S3 so that even GitHub Actions can always refer to it. Okay, so I'm going to configure our Terraform script to do that so that we are able to have one state, okay, one location for state. And before we do that, you should know that the advantage of doing this is that we can now share our state with other developers, okay? And this will enable collaboration, okay? When we shall have a global state in one place, we shall be able to share it with other developers, okay? That's the second benefit. And the third benefit is that we can have what they call state locking, okay? State locking enables you to avoid race conditions. Imagine you were in a team of 3 people, okay? And you're working on this, you have the same Terraform infrastructure and the same Terraform state. State locking means it will prevent more than one person to work on the file at the same time, okay? So we cannot edit the file at the same time or update the state or make changes to the state at the same time. Only one person will be able to change the state at a certain point. That's the advantage of state locking, okay? But state locking is only possible if you have one source of truth, okay? In our case, we're going to set up a remote backend on AWS S3. So this is very key to understand. So now let's now write some code. So to set up a backend, you need to set it up in this Terraform block, okay? In this Terraform block, I'll come down here, put a new line, okay? And say backend. So create a backend block. So Terraform is not about blocks, okay? So you mention the name of the block, okay? Then your curly brackets, like that space, okay? Then we give the resource, what backend is going to be. In our case, it's going to be S3, okay? AWS S3. And this backend will be an S3 bucket, okay? To create this bucket, what we do, we need to specify the location of this bucket, where it's going to be located. So you can say bucket, okay, will be equals to, I'll call it arrow dash bound dash ventures, arrow bound ventures dash Terraform, okay, state bucket, like this, state bucket. This is the name of the bucket, okay. And if I go to AWS, just to show you, right now, you see, I only have this bucket, which was created in around 2022, okay. So we're going to add to it. So after mentioning the bucket, you need to give another property called key, okay. So key is the name of the file, okay. Let me indent this. I saw how guys were indenting their files nicely. Let me indent the same thing so that this equals something in a straight line. So key is the name of the file. The actual file will be called, you can call it the same as this one here in the local file, okay. You can call it terraform dot tfstate, okay. But now it's a good practice to like arrange your Terraform state according to the environment, okay. For example, if it is dev, okay, you'd want to name it as dev slash Terraform tfstate. If it is production, you say prod, okay. If it is staging, you can say staging, okay. So because I'm working on the main branch right now, early on I want, and I'm alone for now on the team, it's a team of one person, I'll just say prod, okay. But later, after testing out my MVP, I'm going to create all these environment: prod, dev, and testing, okay. So we have prod, Terraform state. So that's the file, the actual file. So this file, okay, this file Terraform state will be in a directory called prod in a bucket called Rebound Ventures Terraform state bucket. As simple as that. So yeah, if you're enjoying this and you're learning something, please let me know in the chat. And of course, if this is good and valuable to you, share it with people in your network so that they also learn. Now let's go ahead. The next thing I need to do here is to specify the region, okay? And the region will be the same. I'll not change it. I'll say US East 2. Then to enable locking in the file, like I explained earlier, we shall say use underscore lock file. Lock file equals to true. Okay, it's a boolean. And then also we can enable encryption. It's another advantage I had forgotten to tell you. I want it to be encrypted, okay, for better security. I want to put these things, these all this in a straight line. I just love seeing things organized. So I'll put it there and also put this around the same line. Okay, so the bucket is the bucket name. This is the location of the actual file, terraform.state in a directory called prod, and we're going to see this created for us. The region is the Ohio, which is US East 2. To enable locking a file, we shall say use lock file equals to true. To enable encryption, we set true. Okay. So going forward, we shall not be using local state, but a remote backend. And this is how you set up a remote backend. So ideally, what we're now supposed to do is to come here to AWS, okay, and click on this button. I think this button called create bucket. Let me expand so that you see it better. Supposed to come here and click create bucket, okay. Come here, pick this name, okay. Pick this bucket name. Come here and paste it, okay, and add permissions and stuff like that, okay. But remember, we are doing DevOps, and I want us to be people who can automate, okay, almost anything, okay. So we're going to create a script, okay, to help us automate bucket creation, okay. We should not create the bucket from AWS, the console here. Of course, you can create it if you want, but that's not something I want to do, okay. I want to avoid that, okay. And if you create it after this, I mean, if you create it on your console here in AWS in the UI, and you push this to GitHub, it will work, okay, and it will be very okay. But I don't want that to happen, okay. And in fact, before that, I also want to make sure I stop this instance and terminate it so that when we push, we have something fresh we're starting from. So I'll terminate this. Okay, let it terminate. So to create that bucket, remember at the beginning we installed a tool called AWS CLI. Okay, we had AWS CLI. In case you've not installed this, please make sure you install AWS CLI. That is how you'll have this working. Okay, so now let us go ahead to write a script, okay, which is going to be responsible for creating for us a bucket, okay, just this bucket. So I'll come in the same directory, okay. I can call it maybe AWS bucket. Can call it AWS bucket creation .sh, okay. Then I'll create a shebang. Shebang is simply a hash, a pound like this, and an exclamation mark, followed by a path to an interpreter which will be responsible for executing this file. And the path that interpreter is called /bin/bash. So we shall be using bash to execute the code in this file. If, for example, you want to do Python, make sure this points to your Python interpreter, the absolute path to your Python interpreter on your machine, okay? Or probably Node.js, you do the same thing, okay? So for many cases, I'm using bash. Then on the next line, I'll say set -e. I like AI. So -e simply means that when an error happens, please exit, stop terminating. Because if you don't, imagine you had a command like ls -l, then you have another command called maybe cd, okay, then echo. If you don't put -e, okay, and ls fails, okay, without minus in case this is not around. If ls fails, okay, it will print the error of ls and continue to cd and continue to echo. But in the event that ls fails, we want it to stop at ls, okay? We don't want it to continue to cd. So for that to happen, we have to say set -e, okay? As simple as that. Then x, what is x? For x will print out each command that is being executed in full form. And it helps you with debugging to know, okay, what I'm seeing right now, what command was run. You'll see it just above, okay? And please, you can try it out on your machine. And you'll see that what I'm telling you is true. But every time I tell you something, please make sure you try it out and prove it, okay, for yourself. So after this, what I'm going to do is to create a variable, okay? I'll call it account ID. It will be responsible for picking the account ID, okay, from my account. So I'll say account ID is equals to, okay, I look at this. AWS seems to, AI seems to give me the correct thing. So I'll say autocomplete, okay. Then I'm going to explain it to you step by step. This part which says AWS STS get caller identity. I'm going to execute it for you so that you see, okay. I'll copy this part and I hit enter. So you see what it has returned, okay? It has returned the user ID as that, account as that, and this as root, okay? And ideally we should not be using the root user, okay? This is bad, okay? We should use what is called an IAM user, and we shall do that, okay? We shall do that sometime. I'll talk about it probably in a future video, but it is something you can also research about and find videos on YouTube concerning the same. Okay, so do not worry about that. So from that, what we need, so you see what they're doing, they're picking out the account, okay, picking out the account, okay, which is this value, okay, the account ID, and then they're picking out what the text. They're seeing the out display this account ID as a text. That is what the command is simply saying, okay. So this prints out the user ID, account ID of the current AWS user, and it picks out only their account ID, and the output should be text. That's what it means. So let's do a command. The first thing we want to do is to create a bucket, okay? Let's say create S3 bucket, okay? So to create a bucket, I'll use the AWS CLI command, which will be AWS, okay? Then shall use the S3. So let's say S3 API space create bucket. So you see AI is actually correct. Create bucket. Okay. I'm not going to follow AI blindly. Then maybe put that forward slash to indicate I'm going to the next line. Okay. Then see what AI is suggesting. Okay. Probably I can, let me confirm what AI is. I'll say minus bucket. Okay. So after saying minus bucket is simply an option, okay, for the bucket name. Okay. In our case, the bucket name must match, okay, must match the name we specified here in the Terraform block, in this backend block. Okay, here. It must be Airbound Ventures Terraform state bucket. So I can come here and say that, okay. Then space forward slash, go to the next line, the region. I can accept what AI is giving us, okay. All this is correct. Okay, so the region is US East 2. If you come here, you see that the region is also US East 2. If you look at the create bucket configuration, want location constraint, okay, to be US East 2. Want to have that location constraint to US East 2. So that's another option you can do, okay, that we want to constrain it to only that region. So yeah, nice stuff. This is how you can create a bucket using the AWS CLI without going to the UI. And this is why is this powerful? This is powerful because you can do automation. Okay, you can do it in such a way that this, okay, what you're getting here is actually a variable from the terminal. Okay, so that this variable here can be anything. Okay, the bucket name can be anything you pass. Okay, that's the good thing about automation using scripts. You can create a bucket name. Even this region can be automated, okay, like this. So it's also a variable. So it's a variable AWS region, okay, as an example. Variable AWS bucket name, okay, something like that. So you can have a list of bucket names and a list of regions, and you create them using only this script, okay. So that's the good thing about scripting. So let me undo all that. Since it's only one for now, I'll leave it. But I wanted you to know about this, okay? And how easy it can make life for you. That's why I like infrastructure as code and scripts. You don't have to understand. Imagine your AWS UI. Look at all the things, guys. The buttons, so much things to scroll around and click and buttons and whatever. So much pain, man. I don't want to go through all that, okay? That's why even we need the remote backend. So even here, I have to come and delete actually this, okay? All this is painful trust me, whenever you have to do clicks, okay, and navigate UIs and whatever, you'll get really slow, okay. That is not something I want people who are learning with me to pick, okay. We should always try to automate. Sometimes it's good to be a lazy developer. By being a lazy developer, you'll be forced to automate. Say I forgot, this one should be a comment, okay. Should be a comment. So after creating a bucket, next thing we need to enable versioning. Okay. So I'll say point to, looks like even AI knows what I want. Interesting. I think AI knows that because it's a common practice to do when writing, when creating S3 buckets. Okay. You want to enable versioning. Why do we enable versioning? That should be the question you already have in your mind. Why versioning? Versioning helps us in case, okay, every time the bucket maybe is updated, okay, something is updated, maybe for example like the Terraform state is updated, AWS will version it. So excuse me, sorry, so that when something goes wrong, we can roll back, okay, we can go back to a working version. Imagine we have maybe two versions, okay, version 1 works, then version 2 fails, okay. Version 1 of Terraform state is okay, version 2 of Terraform state has an issue, okay. Using versioning, okay, we can go back to version 1 and our application will continue working because the infrastructure will have remained stable with version 1. So that's the importance of versioning. Always enable versioning, always enable, so the things to always take note of, okay. Always enable locking, always enable encryption, always enable versioning. This version is for the bucket. Again, I repeat, enable locking. What does locking help you? it prevents a situation whereby more than one developer tries to update the state file. It locks so that only one person can update at a time. Encryption is good because in case a hacker maybe finds out your file, okay, because the state file has sensitive information, sensitive data. So if it is encrypted, even if it is hacked into, no one can get to see it, okay? Versioning, why? Because in case things go wrong, we can go back to a working version, all right? So now let's continue. So to enable versioning, okay, I'll still use AWS S3, AWS CLI tool, let's say AWS, okay, space, then I'll use the S3 API, okay. I like what AI is suggesting, so I'll hit tab, okay, then explain. So the command is AWS S3 API put bucket versioning, okay. Then this means we're going to the next line. After that, you're saying when you say put bucket versioning, okay, so these are the commands, okay. There's a command called create bucket, okay, which is an argument to the S3 API. So the same S3 API, you can put bucket versioning. But when you're putting bucket versioning, you need to specify the bucket, okay, which is this bucket here. So to specify the bucket, you say minus minus bucket, then the name of the bucket. So this bucket name must be the same as this bucket name. So again, if you were doing automation on maybe thousands of buckets, simply you'll pass a variable here. We say maybe variable back name, something like that, okay? And then so down here, you would put the same name, okay? Variable name like that, okay? All right, let me undo this. I hope you've now understood it. And of course, if you have any question, please don't hesitate to ask. Then now we go on to what else? Version configuration, there's no need actually for that for now. I'll remove this to keep things simple. We need now to set a policy, okay? So policy is all about permissions, okay? You need to set policy, okay? And then policy has to be a in JSON format, okay? Like that. Come here, hit enter. So policies always have to be in JSON format, okay? So now to create JSON, okay? To create JSON in a shell script, you have to escape. Remember JSON works like so, okay? You need like a quote, okay? What's this AI thing doing? You need a quote, okay? A key, like maybe say name, okay, like that, full colon, then you put the name, okay? You put the value. This is how JSON is, okay? Put comma, go back, you have another name, okay? Maybe, I don't know, maybe a read, okay? Then you put another value, okay? This is the syntax, okay? But if you did this in a shell script, you would fail, okay? It would fail because shell would be confused and think maybe this is starting here and ending here, okay? So to tell you that this is actually a code, you have to escape, okay? Using these escape characters like this, okay? A backslash, then the what is it called? The quote sign, okay? That's what you need to do. So for this, I'm going to change. For example, when you're setting the policy, you need to set the version of the policy. I'll say / quote, okay? Then I say version, okay? Then I can AI is saying 2012 1017, okay? And this is actually a valid version, and I'll show you why it is valid, okay? Then after that, we can have the statement, okay, like that, okay? So before we continue to anything else, let me go to the documentation. I show you something where I got all this from. So I got all this knowledge I'm talking about from this Terraform website, okay? When it was explaining how to configure S3, AWS S3 as your remote backend for your state, okay? And they show an example configuration. You see this? It is similar to what we have. And talk about advantages like state locking, etc. Now they talk about bucket permissions. Okay, they say your bucket must have 3 permissions. Okay, permission for listing, which is called S3 list bucket. It must have, so S3 list bucket is a permission on the bucket itself. Okay, then there's what they call S3 get object. Okay, which should be on the actual file. Okay, forgetting the object. Then they have S3 put object, which is the permission for updating the state file. Okay, so this one, listing bucket, is a permission needed at minimum to allow the Terraform to find your bucket. Okay, then what is inside the bucket is the state file. That state file must have 2 permissions at minimum for getting it and for updating it. As simple as that. What are those permissions? Okay, these are the permissions you need. This is how you set the permissions. Okay, you mention the version. Okay, so as you see this, all this is JSON. Okay, this is JSON. So the version is this 2012 1017, which is the same which I also have here in the code. Okay, version 2012 1017. Okay, after that you need this statement. Okay, which has this effect called allow. Okay, what are you, and the action is S3 bucket. Okay, no, the action I mean is listing the S3 bucket. Then the resource is the S3 bucket. Okay, then you have a condition. Okay, whereby the string should equal to this. Okay, then you have another one. Okay, for getting, okay, with the actual state file and putting or updating the actual state file. So this is the path to the actual file. Okay, so then we also have the locking. This is what enables locking. Okay, now this one requires deleting, putting, and getting. Okay, but in a shell script we cannot define it like this. Okay, we have to escape these quotes. Okay, these quotes here. Okay, and actually asked an AI tool to format it for me in that way. Okay, and I copied it somewhere. Let me try to paste and see. No, this is not the one. I need to pick it from somewhere. But it's actually sensitive. Just give me a minute to pick it. All right, so I've got it. So I can now paste. I can now remove this. Yeah, so this is it. Okay, so what I've pasted here is simply the same as what is here. Okay, what is right here, but instead has been repurposed. Okay, has been repurposed so that bash and shell understands what it is. Okay, and you can see this account ID, which I picked up here. Okay, is being passed here. Okay, account ID, account ID. Okay, so yeah, as simple as that. So this is how our stuff is going to work, and we'll have no problem. Maybe it would work with some formatting. Like for example, I can select all this and hit tab. Okay, just put it on the same line. Let me see if all this is okay. Just move the space. Just format it well. Okay, so yeah, this one is a permission for the Terraform state log file. Okay, then this other one is the permission for the actual state file. Okay, and if you can see, if you look at this key code resource, okay, it points directly to the bucket name. Okay, Rebound Ventures Terraform state bucket, then prod the directory. Okay, here prod, then terraform.state, which is this. Very simple. Then the actions which are being allowed are get and put. Okay, so the effect is allow. What are you allowing? Okay, these 2 actions. And who is that you're allowing? The principal is this person. Okay, from this particular account ID. That's why I had to pick the account ID from here. Okay, as simple as that. Then if you look at this, the statement says allow. Okay, allow this person. Okay, to do this action, to list the bucket. Which bucket are they listing? Is this one here. And of course, they have the condition. This is the condition. Okay, simple as that. So maybe one time we can look at policies in detail, but that's how simple it is. So after this, I can now run the script to create the bucket. Okay. First, I can use this, can clear, maybe first of all, change its permissions. Okay. Say u plus x, it's in Terraform slash, I don't know why it's not being picked up easily. Chmod u plus x dot terraform slash AWS. Okay. I've enabled execution permission on it. After enabling execution permission, what I now need to do is now execute it. Okay. I can now say dot terraform. Okay. AWS bucket, but I need to use only one dot. Okay. So that it's being executed. So if I execute, says no such file directory. Okay, let's go into it. Slash cd out. Okay, then I cd to the Terraform directory, clear the screen, and then execute it directly. Okay, so you see, there it is. So yeah, I think it is says AWS error. The following arguments are required. Versioning configuration. Okay, but I think it actually worked. Okay, so if you look at this, we have the account ID, we have create bucket. Okay, the bucket with all this. Okay, of course we can add the what is it called, the versioning configuration. Okay, we can do that, but what I'm thinking about, let me first go to AWS and see something. What the bucket created, that should be the question you should be asking. Let us refresh and see. All right, here's the bucket. Okay, it was created. If I open it, I will leave Terraform to handle that versioning stuff. Okay, so you see, there's nothing inside here yet. Okay, which is pretty cool. So what do we do next? If I come here, we see that we had terminated the instance. Okay, so and here for the security groups, there should be no security group. Okay, so let's try to commit and push. Okay, later we can figure out that error, but I don't think it should affect us. So I'll say, just to be sure about what I'm committing. So this is okay. So I'll say git add, git commit. I'll say this is configuration. And what I'm doing is create remote state backend on AWS S3. This has to be remote, create remote Terraform state. I want to make it, I want the commit message to actually make sense. So it is configuration or config for configuration and create remote Terraform state backend on AWS S3. Hit enter. That is okay. Then now we hit git push. Okay, now I can go to GitHub and we should expect this to work. So I'll click this, open this job. So you see it was already running. So Terraform init is running. Let's hope I'm lucky. Terraform init has passed. Then I have Terraform validate running. Okay, those two are done now. Terraform plan. The Terraform plan has passed. Now we want Terraform apply. So it is creating the security group. I like automation. Okay, you just do one command and things are happening for you in a declarative way. So you just tell it, I want this, and all the steps are taken care of you. So yeah, it actually worked out for us. Okay, so you see we have the application URL, we have the EC2 public ID and the host name. To prove that, I am going to go to here. Okay, so you see this one was terminated. If I refresh, okay, you see we have a new instance which is running. Okay, which is good. Running, and the status is initializing. Okay, so we need to wait for all the checks to pass so that we can test it out. Okay, if you go to security groups and refresh this, so you see security group has been created. Okay, so if you're enjoying and learning this, please share with people in your community. And this is what they call the solid stuff of software engineering. Okay, that means what separates beginners from juniors. I mean beginners from seniors, or juniors from seniors. They always avoid this kind of stuff, not knowing it's what can help them stand out in the market. Okay, then what else do I want to show you? Our bucket. Now if I refresh here, I see we have the prod folder, and if I open the prod folder, you see we have the Terraform, the tfstate. Okay, and you see it's very small, only 12 kilobytes. So we won't incur a lot. Okay, if AWS was to charge us for this. So this is how you work. Okay, now if I come back here, okay, let us see as the instance, is it done? Okay, you see, so 3 out of 3 checks passed. Okay, so now I can go back to our, I think our infrastructure, I mean our actions here on GitHub. And if I click this link, you see our API is working. Okay, our API is working like we expect. But now the question should be, since we have a remote backend, okay, if I rerun this job, okay, which is now using this remote backend on AWS S3, this backend should not fail. I mean, the actions should not fail like they were failing before. Okay, it should run, okay, smoothly. Okay, because why should this run smoothly? It will using this remote backend here. Terraform will know that it has a security group called Airbound Ventures already created. It will know that it has an instance, okay, already created on AWS, and there's no need to recreate them, but it can update them in case there's information to be updated. How does it know that? Using the Terraform state file, which we just created here on AWS. It is now global. Okay, we can even collaborate. I can now collaborate with you using this file. Okay, and we have things like encryption to it. We have state locking enabled. Okay, but if we use what we did previously, it won't work. Why? Because Terraform state here is lock on my machine, so I can't collaborate with you. Neither can we achieve locking. Okay, so to prove that we are safe, I'm going to come here to rerun jobs. Okay, rerun jobs. I initially it would running the jobs would fail because Terraform would say, hey, you're telling me to create a security group, but I find it already there's a security group on AWS. You're telling me to create a AWS instance, EC2 instance, but there's already an instance to instance, so it crashes and gives us an error. But in this case, AWS will actually check check its state and say, oh, I've already created this. There's no need for me to recreate it again. And it will pass and be smooth like ever. So going forward, we can always push our code to GitHub and everything will work smoothly. Infrastructure will be created. Our application will be deployed for us. Okay. So you see, it has passed. Okay. I see it has passed. It hasn't failed. Why? Because Terraform used the remote state backend here and discovered that, okay, I've already created this security group. I have already created this AWS instance, and there's nothing for me to update. So I'm not going to update it. Okay, so it passed. If I close this and I run this link again, you see everything is working. Okay, our API is still working. Okay, so this is what I wanted you to learn today. Okay, I've enjoyed doing Terraform. It's been so nice and an interesting journey. Okay, in the next stream, in the next streams now we need to do some cleanup on the back end. We need to add maybe probably payment. We need to start front-end integrations. Okay, so I'm going to start front-end integrations next to integrate all our endpoints with the front end, improve some parts of the back end, maybe write tests, and yeah. Now, so that at least we go towards finishing the MVP as soon as possible. Now, because I want to save on money and I don't want AWS to charge me for something I do not know, for now I'll simply terminate this instance temporarily. Okay, and also maybe delete this bucket for now. Okay. All right, but I guess I'll do this after this video. So let's meet in the next streams where we shall be starting that. But I have an issue that I'm going to deal with next week. Okay, so probably we shall meet 1 week from now, where we shall now do the front-end integrations, move on to payments, and finish the MVP. And actually, I'll test out with my colleagues at the office, and then I'll come back to show you the feedback. Probably even live. We can even do a live testing on the market. So bye for now. Happy learning. If you're enjoying this and you're learning something, please share it so that people learn this and like it, so that YouTube knows that you like this. Okay, and subscribe so that YouTube knows that you like this and we build an awesome community. Bye for now.